Radovan, so what are those free hard-earned lessons that have been building sustainable machine learning platform? Please, Zoom is yours.
Lukash, thanks for your words. So if you want to be successful with your machine learning operations, you need to be successful with your machine learning platform first. And the reason I know this is that we built such a platform for banks and insurance, and it's based on Kubernetes and Kubeflow. And we, as Credo, we specialize in helping financial institutions across Europe with their machine learning operations. So with this seamless transition from POC phase to real industrialized models. So running a machine learning operations is a bit like running a Formula One racing business. In order to be successful in the Formula One racing business, you essentially need three things. You need a car with a top-notch ergonomics, such that it's easy to drive for the drivers. And you need a car that is built from a cutting-edge technology, such that it's powerful, reliable, and easy to maintain for the engineers. And you need to generate return on investment from this car. And that happens by winning races and selling commercial stuff, etc. And likewise, in order to be successful in the machine learning operations, you need to have a platform that has a top-notch ergonomics, such that it's easy to use for the data scientists, and they are actually attracted and like to use it. And you need a platform that is built from the cutting-edge technology, such that it's scalable, powerful, reliable, and it's easy to maintain for the platform team. And you need to generate return on investment on this platform. And that happens by seamlessly turning your machine learning models and analysis into machine learning products. So real software applications that are running 24/7 and that are monitored. But establishing and maintaining such a machine learning platform is not an easy task nowadays. So you have like literally hundreds of eligible tools, and there is no such a thing like off-the-shelf platform that you would just pick, plug and play, and everything would work out of the box, and you would cover the entire machine learning lifecycle. So what you need to do, or what actually companies end up doing, is that they are stitching together different tooling in order to provide for data scientists all the functions that they need. And the purpose of my talk here is to help you kind of to share the three hard-earned lessons, three requirements, if you will, that you need to have on your platform in order to make this a successful story. And these three topics will revolve around the tooling, the ergonomics of the platform, and the return on investment on the platform. So let me start with the first topic, and that's the selection of the tooling. Now, there are a lot. I mean, it's really a jungle. There is currently like 300 machine learning tools on the market, and if we broaden the scope to general modeling tools, the number is even higher, and the number increases as we speak. There are at least 6 machine learning frameworks that I can think of that the data scientists like to work in. And there are at least 5 languages I can think of that these guys are writing their code in. And then you also need to take the tooling, the frameworks, and the languages, and you need to run them on the top of certain infrastructure. And that can be either cloud or you can run it on premise. So what I'm trying to say here is that there is really an immense amount of ways how you can assemble a machine learning platform together. And there's also an immense amount of ways how you can go wrong about this. And if this doesn't seem intimidating enough or complex enough, then you can continue with other things you need in machine learning platform, like versioning tooling, orchestration frameworks, workflow managers, inference tooling, and so on and so forth. So what are the things that you should ask for, or what are the things you should actually not ask for when you're building a machine learning platform? And these things you should be asking, if you're a manager, these things you should be asking to your data scientists, but mainly to your platform team. And The first thing is about legacy. You know, tools, they come and go, and so do the companies behind these tools. So roughly 2/3 of the tools, the 300 tools that I mentioned in the previous slide, they are startups, and the failure rate of startups is like 90%, something like that. But it's not only about startups. The big ones, they fail too. Just remember, for instance, the Hortonworks story. So when stitching together this tooling, just think about where will your favorite tooling be in 2-3 years. And what the thing that you should ask for is to have a platform that has ability to adapt very quickly on this market of tooling, where the change is the only constant, really. So continuing in the story of the interlinked tools, another thing that you should focus on is that when you have a lot of these tools stitched together, they need to exchange information somehow. And for some types of information, like data, for instance, this is a solved problem already. It's not really hard to exchange data between different types of machine learning tooling. With models, it's also going quite well. So there are some standards like PMML, ONNX. You can wrap your models in the Docker containers and exchange it that way. But then there are other types of data, like metadata, for instance, for which there are no standards whatsoever. And metadata are really important for MLOps. So when you are picking, for instance, your metadata caption tool, be sure that you are able to migrate it easily next time when there is a better one popping up on the market. And chances are that it will happen. So aim for a minimal hassle when migrating when changing and switching the tools from one another. Because every minute more you spend on migration, you spend less on data science. And it's actually data science that is producing the economic value added, not the tooling itself. Now, continuing the story of the interlinked tools, another thing that is quite hard to set up is to have a consistent security monitoring and logging from day one or day two. And with the security, it's really a binary game. So either you have a complete security, or you have non-security whatsoever. And having non-security, that can have quite an operational implications. You might run into the accidents where data scientists are deleting models of their colleagues or data accidentally. I've seen these things happening many times in banks. Or even worse, if you don't have proper logging, there are models that are running for months with a model bias, so they are not producing a good predictions. But no one ever even notices because the monitoring is not set up properly. I've seen this one happening too. So what you should ask for your platform team is to build a platform that has a consistent security monitoring and logging from day one. And the final requirement is about lock-in. And at this point, many of you might go like, yeah, just don't tell us about the no locking, because that's pure Fata Morgana. And yeah, I completely agree with you there. But the other extreme, where you are fully locked into a certain vendor and you are at the mercy of that vendor, that's also not a situation where you want to end up, right? So when designing this machine learning platform, aim for realistic possibility for a lift and shift scenario. So you lift all the machine learning tooling from one infrastructure and you go to another one. And that will basically secure that you are always up to date with the most powerful infrastructure at the lowest possible costs. Because infrastructure is a commodity, so there are many providers. And yeah, going back to the parallel with the Formula One, it's something like in 2018 when the Red Bull team completely switched the engine from one season to another. So you should aim for these type of things. So what are my suggestions for the first topic, for the selection of the tooling? Well, be ready to constantly adapt and integrate, because the tooling is evolving extremely fast. There is no such a thing as canonical stack, a tooling that would be acknowledged by everyone on the market. Aim for the security monitoring and logging from day one, and that's a hard one when you have this patchwork of tools. And treat infrastructure as a commodity. So yeah, be ready to switch infrastructure whenever prices go up or something else happens. And a great way to go about this, to achieve these requirements, is to build your setup on a cloud infrastructure and put Kubernetes in between the cloud infrastructure and your machine learning setup as a kind of an interface that will shield you from the infrastructure. All right, so that was about selection of the tooling. So that was the first hard-earned lesson. The second lesson is about the ergonomics. You know, when you sit around one table, people who are concerned with the machine learning platform, so first of all, data scientists, but then data engineers, architects, like IT architects, then security experts, managers, and so on and so forth, the discussion tends to become extremely complex, extremely fast. But if you think about it, the platform is there primarily for the data scientists. So it really has to work for them. It has to feel right for them. And in order to make it feel right for them, you basically need to cover three kind of layers or levels of ergonomics in your platform. The first level is the deepest level. And on the deepest level, you care about covering the machine learning lifecycle. So yeah, end to end. And the machine learning lifecycle, that's things like make data scientists be able to access data, make them available to train and tune and hyperparameter and do hyperparameter testing on their models. Make them able to turn their models into these applications, into these machine learning products seamlessly. So give them proper tooling for that. And then when they are running as these applications, be sure to monitor them. And so these are the basic concepts. And in a nice setup, you have like a gluing mechanism, pipelines. So that's the white tubes under the golden icons. And these pipelines are basically a Swiss Army knife with which you can achieve all of these functions. And in the ideal world, these pipelines can collect some metadata. And here we are coming really to the core of MLOps. And each of the pipeline can collect what has been done when, with which kind of results and store it centrally. And these metadata are really then the currency of MLOps. That's really what makes it happen. Without metadata, you cannot go far, honestly. And yeah, just to mention, for instance, for the deepest level, the good tool to be used on Kubernetes is called Kubeflow. That's what we use. Now, okay, if you have covered the deepest level, then you gave an ability to do data science for one guy. But typically, you have multiple users on your platform. So, and in that scenario, you want to give them some kind of a corner or sandbox where they can work with their dedicated tooling and their dedicated resources. And that's the concept of a workspace. So have multiple workspace for multiple users, and these are shielded in a way, so they are not interrupting one another. But typically, you want people to collaborate, right? So you want that you have under certain projects, you have multiple workspaces, and people can share code, models, and data. And on the top level, you have, you want to host multiple projects in an environment that is dedicated for the experimentation. That's a lab environment, and then you have an environment where you are deploying the machine learning products pretty much, and that's called factory. So regarding the ergonomics, my suggestion is to require the following. So require the three levels to be covered. The deep level, which is the machine learning lifecycle, so things like models, artifacts, etc. the mid-level, which covers the collaboration between data scientists, and the top level, which covers the two environments, so the lab and the factory. All right, so that was about, we talked about selection of the tooling and about the ergonomics of the platform, so how it should feel and how it should be organized. And the final thing is about the return on investment, and that's maybe the most important one. So, you know, machine learning as such is extremely intellectually stimulating, and it's a great fun as well. But machine learning is really a tool. That's not the goal. The goal is to create economic value added for your company. And the only way to create economic value added for your company is to have revenues exceed the costs. So let me break it down for you how you can achieve this with a machine learning platform. So obviously there are two sides. There is the cost side and the revenue side. On the cost side, the first thing you have to decide is whether you're going to buy a platform, like a ready-made product from an external vendor, or whether you're going to build it internally. And when you decide to buy it, the drivers of the costs are the infrastructure. So you need to run your platform somewhere, the license that you pay to the vendor, but then also a scale of it. There are certain plans that looks extremely favorable when you have few users and one or two models in the air, but then once you start to scale up, the equation reverts. And then there are the lock-in costs. So actually, how much would it cost if you would like to migrate to another infrastructure provider, for instance, or if you want to go back from cloud to on-premise as a result of certain regulation or whatnot. And on the build side, so if you decide not to buy a ready-made product but build it internally, you also have to pay for infrastructure. But then you need to have an internal team of IT specialists, if you're lucky to have them. There is not so many around nowadays that can build a platform, integrate it, and maintain it continuously, such that you have a continuously running platform. And then there are the opportunity costs, like from our experience in banks and insurance companies, when they decide to go down this path, it takes roughly 6 months to 2 years to land the platform completely, from first day to a platform where you have multiple teams running on it and producing their machine learning products, deploying them seamlessly, etc. And for these 6 months to 2 years, you are not actually producing machine learning products really, and you're not generating the real value added. So you are foregoing a profit that you would normally be able to earn. Which brings me to the positive side, to the revenue side. So what is it that makes the revenue of your platform? Well, the first thing is, as Alessandra also mentioned in the previous talk, aim for the real products, for the machine learning products, for the industrialized applications, not for the POCs, not for some analysis in Jupyter notebooks, because these are not really generating value added, or maybe like ad hoc. It's nice, it's inspiring, but that's not the real hard money. It's the 24/7 running up that are doing this. Focus on the efficiency. Again, coming to the talk of Alessandra, who mentioned that they are about to launch 200 models in the air. If you have 200 models in the air and they are tied to certain set of data, and there is a structural break in these data, like for instance Corona, which really made the time series look differently, many of these models might become obsolete in no time. And then if your business is tied to the decisions that these models are producing, you really need to be efficient in retraining and redeploying these models. So focus on that. Things like if it takes 1 year to put model in production, you're not going to be most efficient. Most probably you're not going to be very profitable. You really have to be fast. It has to be in terms of days or weeks at max. Another thing is evaluation. Do you guys actually know how much each model that is running produces? What is the real value added in terms of money generated? not in terms of some kind of like Mickey Mouse money, but real money. How much money the model generates compared to how much it costs to produce that model. So the salaries to the data scientists, the infrastructure that it's running on, and so on and so forth. So that's another thing to focus on. Always evaluate each and every model. And then it's the scale. And the scale is basically, I truly believe that you can only make the story break even if you go with a lot of models. I don't really believe that you can have like 2 or 3 almighty models that will make this story break even, because typically the costs on the platform and on the people working on the platform exceed the value added from these few models. So it is the scale that makes the story break even. All right, so I'm running out of time, so I'll just summarize. So in summary, there are 3 most important points that I would like to take away. The first is go with the cloud infrastructure and with Kubernetes, because machine learning tooling is evolving fast and you need to constantly adapt. Think about ergonomics, because the platform needs to feel right for the data scientists. And focus on the return on investment, because without return on investment, you will never make it. So when you go back to your company and start discussing the next design platform, just keep this picture at the back of your mind, because it might help you to land a sustainable platform. All right, guys. So this is it from me. Thanks a lot for your time and attention. Yeah. If you would like to talk more, visit our booth or contact me or my colleague David, who is in the conference as well. We are Credo, and we build machine learning platforms for financial institutions.
Thank you.